Bismillahirrahmanirrahim. I'm going to start now. Question is October 2017 in variant 11, question number 4, and this topic of differentiation. So we can see here machines in a factory make a cardboard cone of radius RH height. Okay. It mentions that volume, this formula of each cone, you know it very well. And but is this a connection is given from him? Okay, use these two connections, two links, and try to make this one. Best technique, these kind of formulas, whenever you will see one thing here. Look in this formula, what we have V for volume, R for radius, P for pi, but we don't have H available here. So it means this formula, we don't have H. So what is not there in the formula, I will make a subject. So let's see now how to make sub. So first of all, equation number one, equation number two, one gives us what? Simple make H subject 18 minus R, and this value of H I will replace there. So whenever we have more than two equations given by him, we have to eliminate any one variable. It depends upon the demand of question. So this value I'm going to replace here. I'm saying here, put in 2. Put in 2. When I replace in 2, V for volume, 1 by 3 pi R square time to H. Now this whole thing going to multiply inside 1 by 1. So when this multiply with 18, 3 6 are 18, and I get 6. So 6 pi R square. And when this multiply with R, I get a 1 over 3 pi R cube, because R squared times R give you R cube. And our target is achieved. So we have done it. Now let's go for next plan. And what is the next? He's asking us, look at here, R can vary. Whenever he can say R can vary, so it means differentiate with respect to R. But what differentiate? Naturally, you can see that volume will come here. So d volume by d radius. This is our target. Find the non-zero value of R, first job, and show that the stationary value is maximum. It means we have to go for second differentiation. So first of all, you know it very well, whenever looking for stationary value, we always plug in first differentiation equal to 0. So let's start. So d volume by d radius. So 2 comes down, and you know it 6 pi is a coefficient. So just keep whole as it is. And what is R squared derivative? 2 comes down and power 1 less. The whole coefficient will stay as it is, untouched. And what is R cube differentiation? 3 comes down and power 1 less. So now I simplify. 2 6 are 12. I got a 12 pi R. And this 3 cancel out. I get a pi R square. I got the first derivative very clear. Similar, if I go for second differentiation here, d2v over dr2. So again, same story. This is R derivative is 1. Okay, 1. This is a 1, so 12 pi keep as it is. So t pi as it is into 1. And what is R square derivative? 2 will go down and power 1 less. It means pi as it is into 2r. So ultimately I get 12 pi minus 2 pi r. Second derivative I got even. And this one, what is the plan? This is a second derivative which I will use later on for the nature. And now according to condition for stationary point, I will plug in dv over dr is equals to 0. And as I plug in 0, you can ask me, so why 0? Because he said that find stationary coordinates. So when I put 0, I get 12 pi r minus pi r square. Now you know it very well what is common from both, pi and r common. Okay, so when I pi r common, I get this one from here 12, and here I get r only equal to 0. Now onwards, you know it, when the product of two part equals to 0 comes, so what we do, either first part equal to 0, I mean this equal to 0, or second part equal to 0, 1 by 1. So pi r equal to 0 and 12 minus r equal to 0. And this pi can go under 0 and can be 0. But r cannot be 0. Why r cannot be 0? In any cone, when the radius is there, if radius becomes 0, so it means this distance becomes 0, means there's no more cone available there. No more cone existence is there. So which is not possible. That is why I wrote r cannot be 0. And r is coming 12 centimeter. And that is why if you see the given the question, he's saying non-zero r value. So that is why I got two answers. One is real 0 and another one. And now he said, find R. I have done it. And he's saying, show that it has a maximum volume we are getting for it. So let's see how we can find nature. I'm finding the nature heading here, nature. How to find nature? You know the criteria. I will plug in this 12R value here. If answer comes positive, point of minima. If answer comes negative, point of maxima. So let's try. So D2V over DR2, 12 pi as it is, minus 2 pi, and this 12 goes there. When 12 goes there, I get 12 pi, and I got 24 pi. And I'm getting negative 12 pi, which is a negative. It means it's a maximum volume confirmed. Because you know it very well, when I get a negative, it's called point of maxima. If I get a positive, point of minima. So I have done it, alhamdulillahi rabbil alameen. Let's go for the third and last part. Third part, he's asking, find the maximum volume of the cone. So it means that radius I will plug in here, number one. And that can be made so simple. R value, which is R value here, I will plug in that equation from where I started differentiation. I mean to say, I started differentiation from here. Yes, here I will plug in. So 6 pi r squared. Sorry, not 6. Let me check. Yeah, 6 pi r squared. All right. And 1 by 3 pi r cube. Okay, I will replace this 12 value in the whole equation, and that is giving me maximum volume. And let me complete. So I believe this is clear, and let's complete it. So 12 to power 2 into 6, and minus 1 divided by 3 into 12 to power 3. And if you check it, it becomes 288 pi centimeter cube. In terms of pi, or you can give in a, because he did not mention that in terms of pi, you can say approximately 905 centimeter cube volume of this part. So there's a find the maximum cone volume of cone that we can make from this machine. So I hope so the point is very, very clear.